Right, well, I kind of messed that last bit up, right? But here we are. Yeah? Are we good? Can everyone hear me all right? Is everything good? Yay. Woo. Cool. Right, glad to see so many of you here. All of that music that you were just listening to was written by Kevin MacLeod and is available at incompetech.com. I'll put a link in the description. It's licensed under the Creative Commons license, which means that I can use it royalty-free as long as I attribute the creator, who is Kevin MacLeod. Okay, so yeah, pretty much every single piece of music that you hear over the top of a YouTube video is probably written by Kevin MacLeod. So yeah. Anyway, I think I've got the intro mostly sorted now. A couple of bugs to iron out, but whatevs, right? Did all the sound play all right on the intro? Just out of interest, just wondering. Cool. Right. Okay. So, weird lesson. Well, not that weird, but this is sort of like the second half of the malware lesson. Last lesson we looked at malware, we looked at viruses and trojans and all that nasty software that can infect your computer. The fade was a bit long between music, but it was fine. I'll get better, Sol, I promise. Right, what am I doing now? Yeah, so viruses and stuff. Can someone tell, just to make sure that you were actually paying attention last lesson, can someone tell me the difference between a virus and a worm? Worm fills your computer's files with shiz. Well, what does a virus do? Virus infects files. Yeah, what do you mean by infect files? Changes files. Good. What does it change the files to? We're getting closer and closer to a great answer here. Yes, the virus injects its own code into a file so that it can replicate. What does a worm do? It's just self-replicating. Good. Whereas viruses change files to more viruses. Brilliant! Okay. Well, a virus doesn't always pretend to be useful. It might inject its own code into other files which are perceived as being useful, but which is the type of malware that pretends to be a legitimate file, and then when you run it, it unleashes havoc on your computer? What's that called? It's not a worm, it's not a virus, it's a Trojan. There we go. Excellent. Thank you, Tommy. Thank you, Louis. Thank you, Duke Aries, whoever that may be. Some viruses can only inject into a .exe. Yeah, that's true. There's oh, it's Connor, right? Okay. Cool. Well, yeah, good. Right, you guys seem pretty on the ball. One thing that I want to point out: thank you to those handful of people that submitted their network policies work that I set a while ago. Some of them were very comprehensive. Some of them were a little bit sparse, but still showed me that you understood the point of that. If you have not yet done that, please do it as soon as you can. If you need any help on that, then hit me up on Discord or drop me an email, and I can go through it with you. Cool. So we've looked at malware. We've looked at the stuff that your computer doesn't. Wait a minute. Let me turn the pointer on here. I wonder if there's a way I can get it so that this thing here doesn't appear. Yeah, I don't know. Anyway, we've got the pointers. So So yeah, we had a look at malware, which is the actual software that gets installed on your system, but it's not the only form of attack. So this lesson, this is what we're going to have a look at. We're going to have a look at the horrors of data interception, denial of service attacks. There's two types of denial of service attacks. There's the standard denial of service, or DOS, or DOS, some people say, even though DOS is also an operating system. There is also distributed denial of service attack, which is the more frequently carried out one, which is the DDoS. So we'll have a look at that. SQL injection as well. I have a feeling that SQL injection might go... the specifics of SQL injection probably going to go over the top of your heads, but I've created a little website example which I will share up on the internet for you, so you can have a play around with it yourself. You don't need to understand exactly. Sorry, I think I've got a chest burster or something. You don't need to understand the exact syntax of the SQL injection. You just need to understand that certain websites are vulnerable to this sort of attack, and I'll show you how it works. And then brute force attacks. You guys, we've already done some stuff with brute force attacks, right? Yeah, we'll just recap that. Are you sure it won't have malware? What won't have malware? What, my website? No, my website is malware free. Guaranteed malware free. I wrote it this morning. Anyone know how to make the chat an opaque overlay on the full screen video? Well, I know how to do that on Linux, at least on my Linux setup. I just press the Windows key and T, and then the... I can hold down the Windows key and scroll the mouse wheel to change the transparency. Don't know if that works on Windows. There you go. Out of interest, Tommy, how did you do it? So that everyone knows. No, he's had enough. Okay, so without further ado, let's have a look at this stuff. So the first thing. 3 dots, mate. Yeah, I got you 3 dots. The first thing that we're going to have a look at is data interception. I've got a little diagram here. Data interception is also known as a man-in-the-middle attack, or MITM. Okay, that's worth putting in your notes. You might have noticed throughout the course of these videos, I haven't specifically said to you, write that down. That's because I'm leaving it up to you to write down the important stuff, but this is definitely an important thing. When something is intercepted, it means someone gets in the way of it. In this example here, Alice wants to send a message to Bob, but naughty Mallory gets in the middle, intercepts Alice's message. Okay, now I've got a question for you. How can Alice prevent Mallory from reading the message that she sends to Bob? Yeah, I mean, encryption is the sensible answer there. Okay, now the problem here is that if you encrypt your message, right, Mallory gets in the middle. She can't read the message, but maybe she doesn't need to, because what Mallory can do, and this, a man-in-the-middle attack, let me stress, a man-in-the-middle attack is not someone getting in between and reading your messages. That's not what it is, okay? What Mallory actually does is she takes Alice's message, she discards Alice's message, and she will send an entirely different message to Bob, okay? Like, imagine you're writing a love letter to your crush in your lesson, right? And you write, I love you, L-U-V, and then a space, and then the letter U, and you draw a picture of a heart, and then you fold it up, and you say, psst, pass this along to whoever, right? And someone someone gets hold of it, opens it up in the middle, sees what it says, and what they do is cross out the love and they put "I hate you." Yeah, and then they pass it on. What happens? You end up with some horrible EastEnders nonsense, right? Do you see what I'm saying here? So, what Mallory is actually doing, it doesn't matter if Mallory can read the message or not. The fact that Mallory is intercepting the transmission, discarding the message that was originally meant to be sent and sending her own message onto Bob, means that Bob receives something entirely different. Okay? It's often used, and this is a very basic example. Alice sends a message to Bob saying, "Watch out, Mallory's around. We don't want her getting our usernames and passwords," or something. Mallory intercepts that message and she sends Bob a message saying, "Mallory's around. Can you just send me what your current password is?" Or something like that. Bob sends the message back to Mallory thinking, well, it's Alice. Alice already knows, what's going on. But Mallory intercepts that message. Do you see what I mean? And encryption will not work, because what Mallory can do is, when she discards Alice's message, she can encrypt her own message and send it on to Bob. Bob receives the encrypted message using a spoof password. He assumes that that's the actual password, and then he thinks he's having this encrypted message with Alice, but is not. It's actually an encrypted message between Bob and Mallory. Okay, it's a lot more complicated than that, but at this level, that's all you really need to know. Okay. So yeah, sneaky Mallory. It's not necessarily Bob's fault, because Bob doesn't necessarily know. Okay. You can try this out yourself. Please don't, but you can. If you go to a coffee shop, obviously you can't because lockdown. But if you were to go to a coffee shop and set your phone up as a Wi-Fi hotspot with the same name as the coffee shop's Wi-Fi, people might end up connecting to your Wi-Fi hotspot, and then, in theory, you could intercept their data on its way to wherever it goes, and you can change that data. Okay? To respond to what Tommy says down here, Bob should at least have some common sense. Bob wouldn't necessarily know that this attack was even taking place. Obviously, the example that I gave you was utterly ludicrous. In that example, Bob should never send his password out, right? But usually, man-in-the-middle attacks are very effective, because for a man-in-the-middle attack to be successful, neither party needs to really know that it's actually going on. Okay. VPN wouldn't necessarily prevent it if the attacker was inside that network, but generally speaking, a VPN is a solid defense against this sort of thing. Okay, if you think about a VPN, virtual private network, that's you setting up your own sort of encrypted stream across various nodes on the internet, so it's as if you've got your own system. And in theory, bad naughty Mallory is not part of that system. So yeah. Now, Alex tuned into my A-level stream the other day, so he already knows what I'm about to say here, right? Whereas encryption is not necessarily a way to protect against this sort of attack, there is a way to verify that the person is who they say they are. And I'm going to give you a clue, even though if you're paying attention, you probably already know the answer to this question right now. Callum's 90-degree angle. Don't know what that means. Just before I move on, though, do you understand what I mean, roughly, by a man-in-the-middle attack? Bearing in mind that this is like very, very simplified. Do you get what I'm saying there? And you also understand why encryption is not necessarily a defense against these kinds of attacks. Sound, fam. I've given you a big clue here. How can we protect against these sorts of data interception attacks? Bearing in mind that encryption ain't necessarily going to protect us. How do we protect against this? Solomon Kennedy says, using a digital signature. Luke says, sign it. Okay. Do other than Alex, who actually watched my A-level stream the other day, can anyone suggest how we might be able to digitally sign something? Or can anyone suggest where you might have seen digital signatures before? Yeah, making it unreadable. I mean, that's kind of encryption, and that ain't the way. Use a graphics tab. Sign it with your private key. Oh yeah, Tommy watched that stream as well, didn't he? Yes. So yes, you are well aware. WhatsApp, no. Passport, no. Metadata, you might be onto something there, Rosa. Okay, so not Bitcoin. I mean, that's payment, right? But when we're talking about digital signatures, basically, without getting into too much detail here, if you want all of the detail on this, you can go and watch my A-level live stream from last week. But the process of encrypting something also allows us to sign something, right? Because if we encrypt a little bit of our message, then it can only, in theory, be decrypted using the password given by the person that encrypted it. Right. The way that this digital signature works is it's not one password both sides. It's public and private keys. It's fairly complicated. Details are all in the A-level stream. But if you encrypt a little bit of it, then when it gets to the other side, if it's possible to decrypt that stuff using the same method that you would do, you know that it has come from the person that says it's come from it. I mangled that sentence terribly. I have to apologise there. I'm really sorry. Now you see digital signatures all the time, right? This is an example of a digital signature that I got by clicking on the little padlock icon in the address bar of your web browser. Now, obviously, this is what it looks like on my operating system. It probably looks different on your operating system. But if you click on the little padlock next to the address bar, you should see something that says something along the lines of connection secure, and there might be a box for more information, and then there should be a box that says view certificate, and there might be some other bits and bobs down there that you can then see. You should be able to see who issued the certificate, where it's come from, and there's all this, like, lots of digital verification. Can you see that? It looks like James has found it. Has anyone else managed to find the digital signature there? Okay, and it's worth noting, right, if you always see that padlock and you think to yourself, oh, the padlock's there, this website's legit, well, just bear in mind Mallory could potentially buy her own digital signature as well, right? They're issued by licensing agencies. You have to pay money for them. They're fairly expensive, right? But just because the padlock's there, that doesn't mean it's a legit company, right? If it's a company masquerading as Google, the certificate should be signed by Google. Does that make sense? Right? If the if you're on a Google website that you clicked from a link in an email or something like that, and you click on the padlock, and that digital signature does not belong to Google, you know that it ain't, that's not a legit site. Does that make sense? Food is not a Boolean response. Cool. Right. What are cookies? This is not really related, although you can exploit people using security holes in cookies. When you use the internet, HTTP is a static protocol. It means you don't send, or information is not stored between different web pages. It has to be passed across in some way, right? And the easiest way of doing it is by storing a little bit of information on your computer, which is just a little file, which is called a cookie. Okay, lots of nefarious websites will use cookies in order to track your movements so that they can build up a profile on you and then target advertising your way. The latest version of Firefox has some tools that prevent, the whole tracking stuff. Okay. So if you want to find out more about cookies, ask me on Discord, and I can fill you in on that. I can give you the rundown on how you can create your own cookies and things like that. All right. Yes, you can look at the cookies that are in use. Now, that's not all of the cookies that are necessarily in use in your browser, but all of the cookies which are being used by that website, I believe. Firefox, next to the padlock, has a little shield icon which allows you to view information about what the website is tracking about you. Okay. But do you understand? Can you maybe type a quick summary in the chat why a digital signature would prevent a man-in-the-middle attack? Okay, why would a digital signature prevent Mallory from sending some nefarious message to Bob? Yes, they are unique, as in each digital signature is unique to the person that has signed it. Can you expand on that word verification, Karen? It's a good word to use. Yes, Alec in there with a pretty decent answer there. Yeah, digital signature will prevent a man-in-the-middle attack because it allows you to check who actually sent it. And Tommy follows up with, if it ain't Bob, you ain't getting the message. Yeah, so when you receive the message, you can see who sent it. If the digital signature doesn't correspond to the person you believe sent it, then you can disregard the message, or you can delete it, or you can alert the other person that there's someone listening in. Okay, good. So out of interest, has anyone ever been a victim of a man-in-the-middle attack, or are you aware that you might have been a victim of a man-in-the-middle attack? Just say yes or no. Well, okay, so what if I was to tell you that every single day in school, technically, you are getting man-in-the-middled by our web proxy every single time, right? Students' HTTPS packets are scanned by our proxy server before they go out onto the internet as part of our network policy, right? It's a security thing. And so what happens is you send a HTTPS packet out to the internet. The proxy server opens that packet, it double checks to make sure everything's all great, and then it will package it up again, it will sign it, and then it will send it off, right? Now, usually that doesn't cause any problems. However, I had some issues getting Git set up on the school system because Git very sensibly checks for man-in-the-middle attacks. And when students were trying to connect to their remote Git server, their packets were being sent out, and Git was saying, wait a minute, the person that originally sent this is not the person that signed it. Because, for instance, if Jennifer was to set up her GitHub account, she would send the packet. It wouldn't be signed by Jennifer when it arrives, although she signed it in the first place, because it's been opened already and then repackaged up by the web proxy. And then when GitHub receives it, it says, no, this is the wrong person. So I had to do a little bit of fiddling around to get that fixed. Okay. Now understand that said man-in-the-middle attack, it's not an attack. It's a security precaution that is carried out for students to make sure that things are set up. But remember what I said about man-in-the-middle attacks being most successful when people don't even know that they're going on? You know, you guys didn't know that was going on, but now you do. Does that make sense to everyone? Excellent. Right. Should we get onto the juicy stuff then? What about this? Down here you can see a picture of exactly what a computer hacker looks like there when they're carrying out a DOS attack. They wear hoodies that are so dark that you can't see their face. They always hack using an iPad, and they use this weird impact printer font as well. When you're carrying out a DOS attack, that's exactly what you look like. Okay, so denial of service, also known as DOS. You'll notice that I've put capital D, lowercase o, and capital S there to separate it from DOS, which is an old operating system. Disk operating system. Okay, now a denial of service attack is where you flood a server with requests so that it buckles under the pressure. Okay, so this would be you sending so many requests to the web server that the web server can't deal with it. Okay, it's almost like when you want something from your parents, say, and you keep asking them for it over and over and over, and eventually they get mad, they tell you to shut up, and then they will take off their belt and then they'll beat you with it. Maybe they don't go that far, I don't know, right? But it's important to understand that a standard denial of service attack, okay, that is lots and lots and lots of requests coming from one system to another system. Okay, so this is not quite the Hegarty maths situation, right? This is one person. You would set up a script or something, you know, which sends out a billion messages a second, like with these requests, right? And most servers can probably deal with that, but some of the lower powered servers might not be able to handle it. What's more effective is the DDoS. So to answer Rosa's question, what's the difference between DOS and a DDoS? Distributed is the extra word here. What does distributed mean? Go on the internet, find me an explanation or a definition for the word distributed. Anyone found out that definition of the word distributed? Shared, maybe? I wonder if I can get Adam Jensen's face to be... Right. Is that realistic? Does that look right? No. Yeah, so a distributed denial of service attack, yeah, it's spread out. It's shared amongst tons of different machines, okay? So the idea is, instead of just this one machine sending tons of stuff, you have what's called a botnet. Now, a botnet is a bunch of computers that have been compromised, usually through the use of malware, like Trojans, so they will respond to a signal, okay? And when that signal is given, every single machine in that botnet starts sending out these requests to a single server. Okay? So this is like, instead of just you shouting at your parents to give you some ice cream or something like that, it's your entire family shouting at just one of your parents to give them some ice cream. Okay? You can imagine they'd probably break down in tears pretty quick. I don't know why I'm using that example. I've never asked my parents for ice cream. I've got a little diagram here. Okay, you can see here we have Mallory here has infected all of these machines here with a botnet. Okay, so Mallory has sent out, over the course of a year maybe, Mallory has sent out little Trojans which have been installed on all of these different machines. And remember what I said about Trojans, a lot of the time the payload doesn't directly cause damage. They'll just sit there on your machine, okay, listening. Your machine is part of a botnet. You probably don't even know it. Okay, it might not even have any performance hit until the DDoS starts happening. Okay, and then what Mallory does is she says, you know what? I ain't doing no maths. Okay, let's DDoS Hegarty maths, she says, and she sends the signal out. And every single machine which is on this botnet receives that signal, and then they all start sending those requests into the server. Okay, it's a lot more intense than a standard DOS attack because the requests are coming from so many different machines all at once. Okay, now it's possible for the same effect of a DDoS to occur even without a single nasty person like Mallory. The example here, all of the GCSE students in the UK trying to log on to Hegarty Maths all at once, the server can't cope with it. Okay, that's not part of a botnet, that's just loads of people. And you see it as well at Black Friday sales. A lot of the time you'll find online stores won't be able to cope with all of the people desperately trying to fill the gaping hole in their life with some cheap technology. And when it gets delivered, they think, you know what, there's still something missing, and they'll never be able to fill that hole. Because that hole cannot be filled by the acquisition of material goods. Okay, but yeah, it's the same with online food shopping now. If everyone is trying to access the server at the same time, it falls over. Okay, so there's two ways that a DDoS can happen. Either loads and loads and loads of people specifically say, let's hit the server right now. Obviously, that's difficult to coordinate, and it can be potentially easy to track. More frequently, what happens is over the course of a while, machines will get infected with Trojans, which make them part of a botnet, and then the command is issued, and then all of the machines in the botnet then start spamming the attack. Okay. Now, if you have been infected by these Trojans, you probably won't notice anything until the command is given, and then you might notice your internet going a little bit slower because your machine's sending out all of these packets. Okay. You might even become part of a police investigation because your IP address has been traced to has been identified as one of the IP addresses that was spamming these packets. Okay, does that make sense? Do we understand? Has anyone got any questions about either DOS attacks or DDoS attacks? Do we understand what they are? Is that yes? You've got questions, or right? Good. Can I repeat what a botnet is? Sure. Okay, so imagine that your computer is fully controlled by you. Okay, it's connected to the internet, and you control everything that happens on there. Okay, happy days, right? Now imagine that you clicked a link on the internet, and a file was downloaded, and you ran it, and it didn't work, and you think, oh, that file doesn't work. And so you delete the file. But the file did actually work, and what it's done is it has set up some code on your machine which just sits there listening for a command. Okay? And it can sit there for years just waiting for a command. Okay? Now, this same thing has happened to hundreds of thousands of other machines. Okay? They're all connected to the internet. Their users, their owners, are completely unaware that they have been infected with this problem, with this code which is listening out for a command. Okay. Then, at one point, Mallory, or one of Mallory's friends, says, I'm going to activate the botnet. They issue a command. That command is sent across the internet to every single computer that was infected by that code. Okay, because those computers are all listening. They're all listening all the time, even though their users don't understand or are completely aware. Right? That code is issued to all of these computers, and then suddenly those computers recognize that code, and they are then set up. There's a triggered response which says, we need you to attack this computer now. Okay, and so simultaneously, every machine that was infected by that code then sends requests to the server to try and smash it to pieces. Okay. Would antivirus pick up the file? Antivirus would probably. Antivirus generally finds Trojans, but the problem is once the Trojan has been run, there's no guarantee that the antivirus will pick it up. So you've got to make sure that you scan any files that you download before you run them. Okay. Sometimes antivirus software will pick up the fact that there's some code running on your computer which shouldn't be running, but that's not really the way that they're designed to run. They're designed to inspect files to search for the sorts of code which has been identified as malicious. Okay, so yes, antivirus software would pick it up, but not necessarily after it's already been run. How do I remove myself from a botnet or discover that I am part of one? You can check to see what packets are coming in and out of your computer. There's software like Wireshark that allows you to see all of the network traffic that's flowing in and out. How can you tell if... I mean, it's... Check for services that are running. You can check in the registry. Usually what happens is... on a Windows machine, there's a big file called the registry, which sets things up to automatically run when you start up. If you run regedit from the command line, on the side panel you'll see a whole bunch of different keys. If you go to H key, local machine, software, Microsoft, Windows, current version, run, you can see all of the programs which are set to run when you log in. You can also check run once as well. You can also go to H key current user, software, Microsoft, Windows, current version, run, and run once. Okay, and you can check that stuff out there. Anything that is set up to run and you don't know what it is, disable it. You know, half the time when people contact me and say, "Oh, my computer's broken, can you fix it for me?" It's crap which is being set up to run in the registry. The first thing that I will do is check the registry, and I will disable all of the stuff which I don't know what it is. You know, if it's critical system files, it ain't going to be in that registry key. You know, it might be things like the sound mixer if you've got a specific sound card. It might be things like the shortcut keys on your laptop and stuff like that. But those files can then be reintroduced afterwards. Okay. Once I found a botnet of radios performing a DDoS attack on a frequency of a local podcast by creating lots of interference. Yeah, obviously we're interested in the networking side of things, i.e., like, you know, data denial of service. But it's, you know, that's the same sort of deal. It's like people causing so much noise in my lessons that no one can hear what I'm saying. Is it illegal? Asks Rosa. Yes, you better believe it's illegal. It's a violation of the Computer Misuse Act, which is accessing a unauthorized access to a computer or device. We will look at that in a later unit, but yes, it is illegal. So, one thing to note, your computer is unlikely to be the victim of a DDoS attack, right? Your computer might be the victim of a DOS attack, but even that's unlikely. Usually, DOS attacks and DDoS attacks are targeted at specific servers on the internet to try and bring them down. However, your computer might be the target of a botnet attack, which will then allow it to be used in a DDoS attack. Okay, does that make sense to everybody? Good. Okay. So with that in mind, and I've got a little bit of a clue on the board here, on the what's it called? Should we call it the board? What are we going to call it? I don't know. So based on what I've told you, how do you think we can protect against DOS or DDoS attacks? House point in it for you, Nikki, if you can, if your guess is correct. Cheese grater will not prevent against DOS attacks. Close the ports. Close the ports would stop a DOS attack, but the thing is, if you are a web server, if you close the ports, it means that not only do you stop the DOS attack, but also it means that no one can actually access your website anyway. So closing the ports isn't necessarily a good thing. Pull the plug. Add restrictions to receiving packages. Block IPs sending excessive numbers of requests. That is a brilliant suggestion. Okay, if you've got a standard DOS attack, yeah. If you've got a standard DOS attack, well, okay. So let me just live in a cave and never use the internet. Remember, right? The targets of these attacks are internet servers. Okay, if they disconnect from the server, there's no point them existing. Yeah, they need to be connected to the internet. That's their thing. So disconnecting from the internet is not really a viable protection against DOS attacks, right? So block IPs sending excessive numbers of requests. If you have a single user sending tons of requests, block that IP address. Okay, you can tell which IP address has sent the request in. You just block that IP address. Okay. In the same way that if you've got if you're a parent and you've got a kid shouting at you for ice cream, if you lock them outside all night, then they can't bother you anymore, and they probably won't want ice cream in the morning. Okay, same sort of deal. Yeah. Okay, so that would work against a DOS attack, and actually that is exactly what servers did in order to protect against DOS attacks, and that was why some bright spark came along and said, hey, I know what we can do. I've got this idea for something called a distributed denial of service attack, right? Because think about it, right? The botnets might consist of hundreds of thousands of computers. Yeah. So if you block one of those IP addresses, doesn't matter. There's still, hundreds of thousands of other ones that are coming at you. Okay. So can someone suggest a similar way that we could prevent against DDoS attacks? Okay. You wouldn't necessarily be able to just block a single IP address, but is there a way we can automate a process or something like that? Surgically extract the attacker's cerebellum. I mean, that's more tricky. Add a timer to sending multiple requests. Can you expand on that? Or can someone... Yes, algorithm. Only allow a certain number of requests per second before it kicks everyone out. Not necessarily kick everyone out, but you're thinking along the right lines, okay? If you get... tons of requests all at once, then you can have an algorithm that says, oi, I think we've got a DDoS going on here. And so, rather than dealing with every single request, you just limit the number of requests that you deal with. Okay, so you can say, right, I'm going to let 3 requests in per second, and I'm going to deal with those. It's like when you go to the shops these days, and you got to wait outside for someone to come out before you're allowed to go in. Okay. So it's kind of like blocking the IP addresses, but what you can do is you simply limit the flow of information. So rather than just allowing all of these requests in at once, you say, right, we've got a limited number of requests that can come through, and we'll deal with each of them in turn. Okay, it slows the server down, but it means that it can still handle all of the stuff that's going on. Is that what a reCAPTCHA does? No. Do you mean the images that check to see if you're human, or a robot? I mean, it's one way of preventing that sort of thing. So the idea is that if you've got a web form, getting someone to actually click on a thing or identify all of the images with fire hydrants in or something like that means that it's difficult to automate that process. So that's not necessarily a defense against DDoS, but that's more of a defense against like spamming message forums or creating a billion accounts and stuff like that. But it does fall into the same category, which is flood defenses. These things are called flood defenses. Okay, that's what that clue was. Look here. That's a flood defense. Yeah, that flood ain't getting onto that road, you know. Okay, so flood defenses that's the common term for trying to limit the number of requests that can be sent at any one time. Make sense? I should be a geography teacher, you're right. I'm pretty damn good at colouring in. Cool. Right. Okay, right. We're going to... Alex, stop or I will ban you. I will institute my own flood defenses and you'll be silenced. I've got no flood defenses. Really? Really? Anyway, right. So that was, we've done the sort of like, not really easy, but the basic stuff. So the next stuff is we are going to have a look at SQL injection. And this is the bit where some of it might go over your head, but I'm going to try and explain it as simply as I can. Okay, so here is a slide for you to make some notes on here. SQL injection, right? SQL is, we're going to have a look at that in more detail when we study databases. It's basically code that allows you to access a database, and it's used all the time in login scripts and any website which is driven by a database backend, which to be honest is most websites these days, will have SQL. Okay. There are lots of different types of code injection attacks. Okay, SQL is usually the most common because it's the one that can potentially cause the most damage. And the way that it works is when you have an input form, instead of typing in things like your username or your password, you actually type in the code which is going to access the database. Okay, I do have a demo here. Right, let me actually access this demo. So here's my little demonstration of the SQL injection here. I've set up this web page. The idea is you type in your username and password. Let's say my username is, I don't know, K Smith, right? And my password is let me in. Yeah, what a quality password that is, right? When I click on login, right, it generates this code. Right, this is the code that is generated to access the password. To access the database and double check to see whether I'm allowed in or not. Okay. So select username password from users, where username equals ksmith and password equals let me in. You don't have to understand that at the moment, but what this basically does is it will pull out the username and the password from a table called users, and it's going to check to make sure that the username is ksmith and the password is let me in. right? If there is an entry in the database where the username is ksmith and the password is let me in, then it knows that I am the legit user, right? Does that make sense, what I've explained to you just there so far? Okay, I haven't got to the injection bit yet. That's just me showing you what's going on behind the scenes when you type this stuff in. Okay, so here's the thing, right? What we can do is we can have a look at how this code works. You will notice whatever I type in the username box appears in here, right? Whatever I type in the password box appears in here. This is going to pull out all of the information where these two things are true, right? So we can break it, or we can inject our own code in here. There's a number of different things that we could do, right? We could do something like this. That. We could do something like that, right? Now, you're probably looking at that and thinking, what on earth is that nonsense that he's typing in there? Okay, when I click login, let's have a look what it generates down here. It now says select username password from users where username equals an empty string or an equals string equals an empty string and password equals an empty string or an equals string equals an empty string, right? Well, an empty string will always equal an empty string, right? And an empty string will always equal an empty string. So that is effectively saying true. So it's saying select username password from users where that is true and that is true. Okay, it's going to potentially let us in. You might also have seen things like this. You might have seen or 1 equals 1 or something like that. You know, that's another. But you'll notice that with this one, the problem here is that it's always going to add that closing quote, which is going to mess things up. There is an even more dangerous thing that we could do. We could do something like this. Drop table users. Right. When I enter this code in here, right, the semicolon marks the end of a SQL statement. Right. If I say, right, that's the end of that SQL statement. Here's a new one. Drop table is going to delete a table from the database. Right. I can even leave that blank. When I click login now, you can see here it's saying select username and password from users where username equals nothing. Right. Well, that's not going to pull any data out. There's probably no users where that's the case, right? But then it says that's the end of that statement, and then it goes on to execute my new statement, drop table users. Okay, the 2 dashes are equivalent to a comment in SQL, so it means that the system's going to ignore everything that comes afterwards. Okay, so that's not going to do anything, but because we've closed the string there and we have ended the statement, we can now type in our new statement, which the database is going to potentially execute there. Okay, so like I said, you don't need to understand the specifics of SQL injection. You just need to understand that what it is typing in these database commands into the text box to allow for like, you know, unexpected code to be executed. Does that make sense? I'm almost done, by the way, guys. If you can just hold off 5 minutes before you go and grab lunch. Anyone want me to go over SQL injection anymore? Does that sort of like make sense? Cool. Okay. There is a website where you can kind of practice this stuff. It's called Alert One to Win. I will put a link to it in the in the Discord and on Google Classroom for you guys. Okay. Now, when we look at how SQL works later on, you guys will learn how to prevent against that sort of stuff. Got another hilarious comic here, stolen from XKCD. I'll let you read that. Little Bobby Tables. Hopefully now you guys actually get this joke and you can see how it's totally hilarious. Basically what's happened here is the student has entered his name as Robert. He's then closed the quote marks. He's then ended the command, and then he's typed in drop table students. Okay, that's going to have deleted the thing. So it's important, though. I have put this on here for a reason. Bobby's mum here says, I hope you've learned to sanitize your database inputs, right? Input sanitization is where you check to make sure that no commands have been entered. There are numerous different ways of doing it. Usually it's what we do is remove any quote marks or replace those quote marks, or we'll have some code which strips out any commands to prevent them from being executed. Okay, I'm not going to spend ages going over input sanitization. That's something that you can do a little bit of investigation on there. Brute force attacks we've already gone over, so I'm not going to spend any more time on brute force attacks. On regarding the Year 11 Discord server link, I will get it. I'll double check that I've posted it up in the classroom. I'll get that up today. So brute force attacks you will know about. It's where you go through every single possible combination of a thing to try and get to the password. We've all covered that, right? And what's the best way, just before we finish up, what's the best way of protecting against brute force attacks? Yeah, make a long password. Good. Right, so before I finish up here, I have already put this up on the classroom, right? But here is your task, and this is for next lesson. It might even take you a little bit of the lesson after that as well. Okay, I want you to write an essay entitled "Malware and Other Security Risks." This is where you are going to explain all of this stuff that we've learned over the course of the last few lessons. Okay. So you're going to explain the different types of security risks, and that includes malware, that includes like hackers and DDoS attacks and things like that. And you are also going to explain ways that individuals and organizations can protect themselves from those risks. All right. I have provided a template of sorts for you on the Google Classroom with a bunch of headings. You don't have to write tons. I'm just really looking for a couple of paragraphs explaining each of the headings that I've given you. Okay. Would we have time? Yeah. I mean, like I said, this is going to take you probably about an hour-ish. And what I'm going to do is next lesson, I will be on the voice chat in Discord, so you can ask me questions in there about any of the things that you are writing about. I can also provide you with some websites and stuff like that. Anyone got any questions about that task? Would you? Yes, I will upload today's PowerPoint. Where did my humanity go? Right, it's not that difficult a task, guys, right? Like I said, I'm not asking for like a massive piece of work. I mean, really, a page of 12-point font is probably going to do it, you know. Yeah, there's nothing stopping you using... I mean, this is not something that you have to sit there in isolation, right? You can use your notes, you can use the internet, all of that stuff, right? The only thing that I will ask is, if you use any information from the internet, please make sure that you say where that information came from, all right? Okay, and also I am here to help you out. I don't want this to be an odious task, and what we could do, if you want, is next lesson maybe we'll do sort of a half and half deal where we have, say, half an hour of some learnings or some recaps, and then half an hour for you to write your essay or whatever. Okay, I mean, the reason I'm setting this is because in the exam there are essay questions, right? So I'm sort of like trying to prepare you for that. Okay. Is viewing intercepted data but not changing it illegal? And that is a good question, actually. I don't think there's specific laws against it. Well, it would depend on the method that you use to intercept it. Can the bops at the start be a regular thing? Yes, they can. I will make bops at the start a regular thing, courtesy of Kevin MacLeod at incompetech.com. So that's all Creative Commons licensed, yeah? Just had a thought, actually, just before we go. No, I don't know if I'm going to be able to do it. Oh, no, I don't. Oh, wait a minute. Wait a minute. Nope. Yeah, no, sorry, I thought I had a video to sort of like play us out, but I don't. Maybe one of you guys could create an outro video for me. That would be great. Let us request our own music. I mean, as long as it is royalty free and licensed under Creative Commons, you are more than welcome to request your own music. Okay. So yeah, make me an outro video, someone, and that's what we'll do. For now, though, if no one else has any questions, I am willing to call this a done deal. No one's got any questions. At least it appears no one's got any questions. Right. In which case, that's it from me. That's it from Adam Jensen. That's it from the Studious Duck. And that's it from Motoko Kusanagi. And that's it from Jojo as well. Shout out to Nicola, who drew this amazing artwork. You know I love it. The end!